Good day, everyone. Welcome back to Mathematics MJ, where numbers make sense. So today we're focusing on grade 10 exponents. So we'll start with law number one. It's just a revision from grade 9, but I'll try and move a bit faster. So law number one. Okay, but before we move to law number one. Let's just define a few things. So you have your A and your X there. This here we call this a base, and then this is the exponent. So even if we are given numbers, this is 2 to the power 3, this becomes your base, and then this is your exponent. So our main focus is here. We'll be focusing here. So we'll be multiplying the exponent, adding the exponent, as well as subtracting the exponents. So now let's quickly jump to law number one. So law number one states that when multiplying the same bases, you add exponents. So an example of that, we'll have a to the power 3 times a squared, which is equals to a to the power 3 plus 2, which then gives us a to the power 5. Law number two, it's about dividing same bases, and then you subtract the exponents. So when you divide the same bases, you make sure that you subtract the exponents. The example there, you have your 6 and then divided by 3a to the power 3. This will give us, so the first thing that you have to do, you take care of these coefficients. So 6 divided by 3, that's 2. And then a to the power 8 divided by a cubed. That's just a to the power 8 minus 3, which is equals to 2a to the power 5. Right? Then let's move to law number 3. Law number 3 is about raising to a power. So this whole thing is raised to a power of n, right? So how do we go about simplifying this? So this thing, it's about multiplying the exponents because the topic is about exponents. So you're just distributing and get rid of the bracket. So you'll have your x and then m times n, which is equals to x to the power mn, right? And then we continue. We move to law number 4. So for law number 4, it's about x, y, and z raised to an exponent or to the power of m. So basically, as I've explained, that this is about exponents. You distribute that exponent m. So before we even continue, we have to assume that there's exponent 1, exponent 1, exponent 1 there. Then 1 times m is just m as well as m there, right? And then, okay, the example for this one, they will give you a to the power 2 and then raised to the power of 3. This will be a to the power 2 times 3, which is equals to a to the power 6, right? And then example similar to this one, you will have your 2a squared and then b to the power of 3. What do we do? You distribute. That's the first thing. And then you assume there's 1 and 1 there, right? This will be 2 to the power 3 a to the power 2 times 3, and then b to the power 3. This will give us 8 to the power, I'm sorry, 8 times a to the power 6 times b cubed. And then you got your final answer there. Let's move to law number 5. Law number 5. Again, it's about removing the brackets, but you make sure that you share the exponent of m. So this, you will have your x to the power m and then y to the power m. And then an example there, you'll have your a to the power, sorry, a over b to the power 3. And then this will be exactly as a to the power 3 and b to the power of 3. Law number 5. We move to law number 6 now. Law number 6 is about a negative exponent. How do you get rid of that negative exponent? You introduce 1 over something, and then you write this as it is, but without a negative exponent. So you'll have 1 over x to the power m. And then the example there, you have your a to the power negative 3. This is the same as 1 over a to the power of 3. And then law number 7. 1 over x to the power negative m. It's the same as x to the power of m. This is the law. So example, you'll have your 1 over a to the power minus 3, which will give us a to the power of 3. Then the last one, law number 8, we call it a property. This is just 1. Any base raised to the power of 0 is equals to 1. Example, 25, a, b, and c raised to exponent of 0. This is equals to 1. So now we can move to our examples. We can start with our examples now. Example 1. We have to simplify. And then we are given 6 x cubed y squared over 3 . So the first step here, we have to use law number 4 to get rid of the bracket. So you have your 6 there. So distribute, we have to distribute 2 there. That's the first thing. This will give us x to the power 6 because of 3 times 2. And then y to the power of 2. And then over 3. Let me just use a different color there to show you that I've removed the brackets. Then we're done. And then you have your x over y there times y squared over y negative 3 there, right? And this part here is the same as 1 over y to the power negative 3. And we said this is law number 7. So this is exactly as y to the power of 3, right? So let's go back and try to apply that. Okay, this is x to the power negative 3. So this will be our x to the power of 3, right? So, and then from here, the only thing that you have to do is to multiply all the numerators and then denominators as well. And then you multiply all the denominators. So you will have your x there times x to the power of 3. It's no longer a denominator. Ne? So the denominators, you only have 3 and y, and the numerators, everything. So now we'll have our 6 and then x to the power of 6 y squared put down here, and then we have your x there, and then y squared, and then x cubed, all divided by 3 times y, right? To the power of 1. Now, let's start with x. 1, 2, and 3. So 6 divided by 3, that's 2. Done. And then x to the power of 6 plus 1 plus 3. And then we done the y. We have your 2 plus your 2 there. Because of this is the denominator, then we subtract. So that's law number 1, law number 6. And then from here, you have your 2x. Now we are adding here. You'll get your 10. Subtract there. You'll get your y to the power of 3. Then you're done. And that's it. That's it with example 1. Now let's move to example 2 quickly. So now we're focusing on example 2. We are still simplifying. So for example 2, they're giving us 3x over 2y all squared divided by 3x over 2y. This is divide 2y. The first step, we apply law number 5. Get rid of the bracket by distributing, right? So this is 3 squared x squared over 2 squared y squared. That's the first step, right? Divided by 3x over 2y. This will give us 9x squared over 4y squared. Times, let's flip now. We'll have your 2y over 3x. So basically why now I'm flipping, because we're moving from division to multiplication. And then from here, you take care of numerators as well as denominators by multiplying. 9 times 2, that's 18. And then we have your x squared y. And then 4 times 3, that's 12. And then you have your y squared x, y squared and x there. And then from here, just simplify. So 18 divided by 12, that's just 3 over 2. Okay, and then there's 1. Take care of x and x. X squared divided by x to the power 1. That will give us 2 minus 1. And y to the power 1 divided by y squared, then you will have your y 1 minus 2. And then this is 3 over 2 x to the power 1, and then y to the power negative 1, right? But this can be expressed as positive exponent, né? So you'll have your 3x over 2 times y. Because of that negative, we have to express it as 1 over. But one would say, I'm confused, how did you get to this step? Let me explain it step by step. So remember, now you have your 3 x there over 2, and then there's y minus 1. 3x over 2 times 1 over y, right? And then from here, you multiply just like that. So you'll get your 3x over 2y. That's the answer there, which is the final answer. Okay, we're done there. And then we move to example 3. Let's move to example 3. So example 3, we are still simplifying again here. So the first thing, we have to convert all the bases to their prime factors. So 27 can be written as 3 cubed, and then x plus 2. 9, that's 3 squared. Then 2x. It's already simplified to that one. And then 81, that's 3 to the power 4. And then you have your x plus 1. And then from here, you apply law number 3. Get rid of the bracket by distributing the exponents. Let's do that now. So you have your 3 times x, that's 3x. 3 times 2, that's plus 6. Done. 2 times 2, that's 4. And then there's x there. Four times x, that's 4x. 4 times 1, that's 4. That's law number 3, right? And then from here, we use law number 1 and 7. We use law number 1 and 7. So let's start with this. 3x plus 6 plus 4x. You multiply the same bases, you add exponents, right? And then now we have to consider these ones. Denominators, you subtract them. So minus, you have your 3x plus your 4x plus 4. And then from here, that's 3x plus 6 plus 4x minus 3x minus 4x minus 4. And then 3x and 3x, cancel. 4x and 4x, cancel. 6 minus 4, that's 2. This is 3 squared, which will give us 9. Then we're done. We got 9 as our final answer. This is example 3. Let's move to example 4. We are still simplifying, and we are given 9 to the power 3x, 12, 2x plus 2, divided by 4. The first thing, converts all the bases to their prime factors, right? 9 can be written as 3 squared. That's 3x there. And then 12 can be written as 2 squared times 3. And then we have 2x plus 2 there. 4, that's 2 squared. 2x plus 4. And then 9, that's 3 squared. And then it's 4x plus 1. From here, let's apply law number 3 and number 4. If you don't remember those laws, you can pause the video and go back to check the laws. I've already explained the laws. So we apply law number 3 and 4. So we have to remove the brackets by distributing, right? Let's do that. 2 times 3, that's 6. And then there's x, we're done. Distribute that 2. So you'll have your 2 to the power of 4x, because 2 times 2x, that's 4x. And then 2 times 2, that's plus 4. We're done with 2. And then 3, you'll have your 2x plus 2. Okay. And then divided by, distribute 2 times 2x, that's 4x. And then 2 times 4, that's plus 8. And then 2 times 4, that's 8 again. So you'll have your 8x there. 2 times 1, that's plus 2. That's law 3 and law 4. And then from here, we use law number 1, law number 6, and law number 7. We start with all the threes. 1, 2, as well as 3. So you'll have your 3, and then it's 6 plus 2x plus 2. Denominator, which means we subtract their exponents. So it's 8x plus 2. We're done with 3. Now we're focusing on 2. So 1 and 2. So you have your 2 to the power 4x plus 4. This is denominator, subtract their exponents. So you'll have your 4x plus 8. And then from here, that's when now you can distribute this -1 to remove the bracket, right? So let's do that. 3 to the power of 6x plus 2x plus 2 minus 8x minus 2, 2 to the power of 4x plus 4 minus 4x minus 8. And then from here, simplify. 6 plus 2, that's 8. 8 minus 8, that's 0. So you're left with what? 2 minus 2, that's 0. So this is 3 to the power of 0. We're done with that part, right? Coming to this one, 4x and 4x will cancel. And then 4 minus 8, that's 2 to the power of minus 4. And then as from here, this is just 1 times 1 over 2 to the power of 4, which is equals to 1 over 16. Then got your answer. Then we're done there. We're done. Now, what happens now when we add or subtract with variable exponents? So what happens if there's plus or minus separating the bases, right? So example 1, there. We're simplifying again. But when we are simplifying, now they're giving us 4 times there's 2x there minus 9, and then it's 3 to the power 2x minus 2 there, 3 to the power of 2x minus 3 to the power of 2x minus 1. How do we go about simplify this? How can we simplify this? So the first thing that you have to do here is to break down the exponents using this law. A to the power x times a to the power y is equals to a to the power x plus y. But you can move from this to this step by reversing. So you'll have your a to the power x plus y, which this can be separated as a to the power of x times a to the power of y. We have to apply the same thing here. So you have your 4 there, and then 3 to the power of 2x minus 9 times 3 to the power of 2x. Now we are separating the exponent. This is 3 to the power of minus 2 there, all divided by 3 to the power of 2x minus, again, we separate the exponents again using this. Then you'll have your 3 to the power of negative 1. And then from here, there's something which is common. We did common factors during the factorization. Now you know how to take out the common factor. So you take out the common factor there. On our numerator, you'll be left with your 4 minus your 9 minus the 3 to the power negative 2, all divided by, take out the common factor, that you'll be left with 1 there. So that's 3 to the power of 2x, you're left with 1 minus 3 to the power of negative 1. And then from here, these two, they will cancel. And then you're left with your 4 minus your 9 times 1 over 9. 1 minus 1 over 3. This will give us 4 minus 1 over 3 over 3 minus 1 over 3, which is equals to 3 over 3, and then 2 over 3 there. 2 over 3, which will give us 3 divided by 2 over 3. And then this is 3 times 2, sorry, 3 times 3 over 2, which is 9 over 2. Or you can just use your calculator. Or you can just use your calculator. Simple as that. And then we move to another example there, which is example number 2. We're still simplifying. Now we're given 5 to the power x minus 1 times 11 plus 5 x plus 1 there, and then 5x x minus 1. The first step there, we have to separate the exponents. 5x multiplied by 11 there plus 5 to the power of x and then 5 to the power of 1 divided by 5 to the power of x plus and then from there you take out the common factor there. Now you're left with 5 to the power of negative 1 times 11 plus 5 to the power of 1. Common factor again, and you're left with 1 plus 5 to the power of negative 1. And then from here, let's continue. And then when you use your calculator from here, okay, this will give us 11 over 5 plus 5 then, with 1 plus 1 over 5. When you use your calculator, then you will get your final answer as 6. And then we're done. And then we're done, just like that. And then we move to rational exponents laws. Rational exponent laws. Obviously here for this topic, you will learn the rules for when exponents are rational. So law number one. Law number one, given a base to the exponent now of 1 over a, express this in a set form. Okay, this is red. It should be inside, and then this one, it should be outside the square root. Here's an example. 4 to the power of 1 over 2. This is equals to 4, square root of 4 there. And then there's invisible 1 there, as well as 2. And this will give us a 2. Law number 2. X to the power of b over a. Again, your numerator inside, denominator outside. So you'll have your b and then your a there. Example, 4 to the power of 3 over 2, which is equals to, so you'll have your 4 there and then 3, there's 2, which will give us square root of 64. Then there's 2 there, which is equals to 8. Law number 3. X to the power of negative b over a. Again, you'll have your x, negative b there, and then your a outside the root. Example 27 to the power of negative 1 over 3. This is the same as 27 to the power of negative 1, and then there's 3 out there, which will give us 3, 1 over 27. And then this is just 1 over 3. That's the final answer. So I want us to apply these rules. I want us to apply all of these rules now. Let's start with example 1. We have to simplify. And then they're giving us 16 to the power of half plus 9 to the power of 3 over 2 minus 5. So the first thing that you have to do, this thing, it's the same as square root of 16 plus same as 9 cubed. And then there's a root and minus 5. So we use rational exponents of law 1 and law 2. And then square root of 16 is just 4 plus this is just the root of 729 minus 5. And then this will give us 4 plus 27 minus 5. Then the final answer is 26. We simplify just like that. And then example 2. We're still simplifying. Example 2 now. So for example 2, the thing show that root a is equals to 2 root 2 without the use of a calculator. Okay, but root 8 is equals to, can be expressed as 4 times 2 to the half, right? And then from here, we distribute, right? So you'll have your 4 to the power of half times 2 to the power of half. And then this is root 4 and root 2, which gives us 2 root 2. And then this is expressed as 2 root 2. Now it's proven. Now it's proven. I hope we all understand. I hope you all understand. Let's move to the next part now. Let's move to the next part. Now we're moving to exponential equations. Exponential equations. Equations involving exponents. Now, for exponential equations, actually, for you to solve for x when it comes to exponential equation, you must fight to get the bases to be the same, and then you drop down exponents, right? So, for an example, if x to the power of a is equals to x to the power of b, where x is greater than 0, but x is not equals to 1, then a is equals to b. This is the conclusion. Let's try to use this on example 1. Let's use this on example 1, where they're saying solve for x. And then they give us 6 to the power of x equals to 36. So this shouldn't be a problem. This is giving us an idea. It's giving us the direction to say, change whatever that is on your right-hand side in terms of 6. So you'll have 6 to the power of x equals to, this will be 6 squared. Same bases are the same, drop down the exponents. X is equals to 2. You are done. Simple as that. And then example 2, we are still solving for x, but now that we are given x plus 4 equals to 4 to the power of 2x plus 9. We have to get the bases to be the same on both sides. But how do we do that? We change 8 into base of 2. And then from here, we distribute so that we can get rid of the brackets. So this is 3x plus 12. This is 4x plus 18. And then from here, bases are the same. Drop down the exponents. You will have your 3x plus 12 equals to your 4x plus 18. And then transpose to the left-hand side. This is minus x. This one to the right-hand side. This is 18 minus 12, which is 6. Divide both sides. So your x is minus 6. We're done. Example 3. Let's move to example 3. So for example 3, we're still solving. Then now we're given 3 to the power 2x is equals to 1 over 9, right? Okay. So you'll have your 3 to the power of 2x equals to 1 over 3 to the power of 3 squared there. And then this can be expressed as 3 to the power of minus 2, law number 6, right? And then bases are the same now. Drop down the exponent. 2x is equals to minus 2. Divide there by 2 both sides. This is negative 1. Your answer is negative 1. Then we're done. And we move to the next part now, which is example 4. We are solving for x again, but then now we're given this kind of an example. So the first step here, I see that there's something that we don't need, which is this number here in front. So since we don't need it, let's just divide by it, both sides. Divide both sides. Now we're left with 25 to the power of x equals to 125 when we divide these two, right? And then from here, this can be expressed as 5 squared equals to, okay, let me do this. And then this is 5 cubed. Then get rid of the bracket there. This is 2x equals to 5 cubed. Now 5 to the power 2x is equals to the 5 to the power 3. Drop down the exponents. 2x is equals to 3. Divide by 2. And then x is equals to 3 over 2. Just like that. Done. Example 5. We're still solving for x, but then now they're giving us 4, and then x plus 6 equals to 1. How do we solve for x here? Make sure that you get your bases to be the same. So 1 can be expressed as 4 to the power of 0. Drop down. X plus 6 is equals to 0, and then x is equals to minus 6. Just like that. Example 6. Still solving for x again. Now we're given 125x times 25 to the power of x minus 2 equals to 25. The first step, you break down numbers. 5 to the power of 3, there's x there, times 5 squared, and then there's x minus 2 equals to 25, which is 5 squared, right? Okay, let's write it as 5 squared to make things simpler for us. And then from here, you'll have your 5 to the power of 3x times 5 to the power of 2x minus 4. And then is equals to 5 squared. Same basis, add exponents. So this is 5. You'll have your 3x plus 2x minus 4 equals to 5 to the power of 2. Now drop down now the bases. So you'll have your 3x plus your 2x minus 4 equals to 2. These two, they will give us 5x transpose. This is equals to 6. Divide both sides by 5. X is equals to 6 over 5. I hope it makes sense. Another example, solving for x. Example 7. Given 3 to the power of x there equals to 1, 5 times 2 to the power of x. Okay, this can be expressed as 3 over 2, right? Times 2 to the power of x equals to 3 to the power of x. Now that you have your 3 over 2, that's the direction, which means I must create 3 over 2 again here. How do I do that? I divide both sides by 2 to the power of x, 2 to the power of x. These two, they cancel. Now you're left with your 3 to the power of x over 2 to the power of x equals to 3 over 2. Can you see now we are getting somewhere? Now, this is 3 over 2 to the power of x. And then from here, you have your 3 over 2. There's 1 there. Same basis, drop down exponent. X is equals to 1. And then we're done. I hope it makes sense. And then the last example, and then we can close our video for today. We're given 25, example 8. We're given 25 to the power of x minus 1 over 5x plus 1 equals to 24. This can be expressed as 5 squared to the power of x minus 1 over 5x plus 1 equals to 24. And then from here, you distribute, you get your 5 to the 2x minus 1 equals to 24. And then from here, you can factorize. This is 5 to the power of x, 5 to the power of x, 1 and 1. This is just difference of 2 squares. And then it's 5x plus 1 again equals to 24. These two, they cancel, they go. Now you're left with your 5x minus 1, that guy there, equals to 24. And then from here, transpose there. So you have your 5x equals to 25. And then this is 5 to the power of x equals to 5 squared. Then x is equals to 2 because the bases are the same. Thank you so much, guys, for watching my video. Don't forget to like, comment, share, and also subscribe. Bye.